Hello, this is Mahendra Dedia. This is the third submodule in sequence used to describe formulation and composition. And this submodule will look at formulation compositions of oil and water in oil emulsions using pharmaceutical and cosmetic as an example. Water and oil and water is the focus of this. And as you can see, in oil and water, oil are the globules and water is the continuous phase. And in oil and water interface is very critical. Water in oil similarly has oil phase as a continuous phase and water as a globule phase. Again, the interface is very important. The future module will look at the double emulsion, water, and water, oil, water, and oil at that later. In future module, we'll look at the double emulsions, water, and oil, water, and oil. Let's look at the examples. This is alpha lipoic acid. It's an antioxidant. And this is formulation A, oil and water cream. It contains the oil phase and an emulsifier. This is a combination emulsifier with estimated HLB of about 12. It has fraction of coconut oil, which has required HLB of about 11, and octyl stearate, again, required HLB of about 11, as emollient built into the oil phase. The aqueous phase has carbomer, acrylic polymer, that gives it rheological properties, and we will see that in a few minutes. It has chelating agents, parabens as preservative, antioxidant, triethanolamine to adjust pH, and water. The active phase is alpha lipoic acid, ALA, which has reasonable solubility, 240 milligrams per liter, and it dissolved in propylene glycol. The lab process, as written in the literature, goes through making of an oil phase and separately an aqueous phase. Both are heated to 70 degrees. It's unusual to see a continuous phase poured into a dispersed phase. However, that was the author's. It is unusual to see the continuous phase poured into an oil phase with continuous stirring. That's what the authors have described. In general, we prefer to add the dispersed phase, in this case oil, into the continuous phase. The active phase is dispersed into propylene glycol and then added to the fresh emulsion. And then it's mixed well to achieve homogeneous mixture. The active phase is ALA, is dispersed into propylene glycol, and then this solution is added onto the emulsion itself. So it resides in the external phase. Propylene glycol is used as a co-solvent with water. Same authors prepared another formulation without carbomer, and it has a lotion type consistency. It has a different, same author prepared a different formulation of alpha lipoic acid with lotion-like consistency. It has a slightly different oil phase that's listed here with required HLBs. It used PEG 75 lanolin as an emulsifier with its calculated HLB of about 16 and added dimethicone copolyol HLB of 3. The aqueous phase is slightly different, has another antioxidant, BHT, had parabens, and pH adjustment with triethanolamine. The active phase is about the same. Again, the process, as authors have described, the aqueous phase is added into the oil phase, which is not general practice. Generally, we like to add the dispersed phase, in this case oil, into aqueous phase so the globules, when they are formed, are immediately stabilized. Let's look at the rheology and the release of active. Without carbomer, the second formulation shows very little yield stress, i.e., it will immediately spread and will have a lotion-like consistency and has a small hysteresis loop indicating slight thixiotropic nature. One with the carbomer has a definitive yield stress at about 70 Pascal, indicating a cream-like behavior, i.e., it requires slight force to start spreading the formula, which is really essential for cream-type formulations. The release of active was measured. Carbomer, being viscous, had slightly slower release, whereas without carbomer, a lotion-like product had a slightly faster release under similar conditions. So one can conclude that rheological properties and the physicochemical properties with and without carbomer have impact on the release kinetics of the active. Let's look at second formulation, which is water in oil. Let's look at the second formulation. It is a water and oil emulsion. It is from Asian journals. And let's look at the second formulation, water and oil emulsion. It has an Asian component to it, as you can see from bamboo hydrosol used as a water distillate, naturally occurring sodium peroxide carboxylic acid, vitamin B5, skin prebiotic, and arginine to adjust the pH. In order to make water in oil emulsion, the emulsifier PGPR is used. This is a common to make water in oil emulsion. PGPR with HLB of 3.5 is used. This is well-known emulsifiers used in food as well as cosmetic industry. Oil components are peach kernel oil, rose hip oil, sacha inchi oil, Peruvian oil that's used in healthcare, vitamin E derivative, grapefruit oil, and yang lang oil. Preservatives is a combination of triethyl citrate and glycerol caprylic and benzoic acid. The process is making an aqueous phase. An aqueous phase pH is adjusted to 5.46. Oil phase is prepared in another beaker, and oil phase is added. Oil phase is prepared in a separate beaker, and gradually water phase is added into oil phase so that water globules are made and they are stabilized by the emulsifier PGPR. The preservative is added at the end, and the stability samples are taken and microbial samples are taken, and rest of the product is filled in suitable containers. So there are claims that can be made with this kind of product as a prebiotic, has a natural vitamin uh, components, as such are inchy oils. Those claims can be put on the label. Let's look at sunscreen SPF 33 emulsion with suspenoids, in this case, water and oil emulsion. The oil component has dimethicone. The oil phase has dimethicone, skin conditioning, sildimethicone, cyclomethicone. These are used to spread the emulsions or creams, and they are very effective. The oil phase has dimethicone components, and dimethicones and methicones are well known for their spreadability and smooth feeling. Hydrogenated castor oil, microcrystal wax, aloe vera oils are used. Sunscreens, benzophenone and octimethoxycinnamate are used. These are conventional sunscreens. Some places they are not acceptable. Zinc oxide, generally nano size, is used as a sunscreen. Phase C, which is aqueous phase, has water, sodium chloride, and titanium dioxide as a sunscreen. Both zinc oxide and titanium dioxide are preferred sunscreen now, so that we do not damage the environment. Rheology, thickening, anti-caking is done by aluminum starch compound, and this increases its viscosity and gives a cream-like consistency. Preservatives are oil soluble, germane too. It includes urea and methyl propylparabens. The lab procedure is phase A, which is oil phase, containing 2 sunscreens, are added and heated to 80 degrees. Zinc oxide is added to this oil phase with a constant stirring, and zinc oxide is not going to be soluble in oil phase, so it would require high speed stirring. Aqueous phase, phase C, is prepared by mixing ingredients into DI water, including TiO2, titanium dioxide. Both phases are cooled to 40 degrees, and then phase C, aqueous phase, i.e. globule phase, is added to water. Aqueous phase, that phase C, is added to the oil phase for water and oil emulsion. The thickeners are added at the end and with high shear stirring. And the final mixture is homogenized for 2 minutes because we have zinc oxide and titanium dioxide. Both are suspenoids, will require high shear mixing. This formulation, according to authors, yields SPF of 33. Let's look at pharmaceutical oil and water emulsion. Clotrimazole is an active, and active phase has a wetting agent with oil and water HLB of about 15 and uses water phase. Oil phase is white petrolatum, mineral oil, and silesteryl alcohol, and uses same agent which was used as wetting agent. Here it becomes an emulsifier at oil and water HLB of 15. Aqueous phase is pretty standard for pharmaceutical use. Benzyl alcohol as preservative, propylene glycol, pH adjustment, and water. Total weight is 1,000 grams. In laboratory manufacturing, aqueous phase has 75% of water, which is 405 grams of it, is heated to 70 degrees. pH ingredients are added and temperature is maintained at 70 degrees. Oil phase is separately heated at 70 degrees and emulsifier is added and maintained, temperature is maintained. Oil phase is prepared in a separate vessel. Petroleum is melted at 70 degrees and rest of the ingredients are added and temperature is maintained at 70 degrees. In this case, oil phase is combined with aqueous phase and temperature is cooled down to 38 degrees. The active phase is separately prepared. The clotrimazole, which is very insoluble and hydrophobic, is wetted using same emulsifier, in this case wetting agent, with water. The slurry of clotrimazole is then added into the emulsion with vigorous The slurry of clotrimazole is then added with vigorous agitation until smooth mixture is obtained. The active phase is prepared separately by mixing clotrimazole with wetting agent in water at 65 degrees. It is cooled to room temperature and slurry of the clotrimazole is vigorously agitated until it's very smooth. Then slurry is added to the emulsion. So clotrimazole is residing in the water phase as an insoluble material, i.e., it is acting as suspenoid. We look at injectable emulsion of oil and water. In this case, the drug is cisplatin. It's an anti-cancer drug. Soybean oil is the only oil used. In parenteral injectable formulations, there are limitations of number of oils and emulsifier that can be used due to toxicity and injection site pain. In this case, egg phosphatide is used as a surfactant or emulsifier, and water phase has pH adjustment, chelating agent, and glycerin. Laboratory procedure is described as the oil phase with active is prepared first and is maintained at 70 degrees. Aqueous phase, water phase is heated and ingredients are added to the aqueous phase. In this case, the surfactant egg phosphatide is dispersed into the aqueous phase and then pH is adjusted between 8 and 11. Emulsification, oil phase, which is a globular phase, is added to the continuous phase, which is aqueous phase under high-speed stirring. Emulsion is homogenized and it goes through several cycles of homogenization until the globule particle size is below 0.2 micron. This is a requirement generally for injectable and parenteral products so that they can be filtered and also they are small enough so that they can be injected without the pain. Product is cooled after each homogenization cycle and the cycle keeps on repeating. Product is sterilized after filtration through steam sterilization, generally done at 121 degrees for 15 minutes. And the product is content are measured at zero point 0.5 milligram per ml.